Hi student, welcome to chemistry class with Odisoya Olaleko Adiola. This video is brought to you by Egotha Virtual Learning. In today's class, we are going to be looking at methods of separation or the separation techniques. Before we go into discussing the separation techniques, we have to understand mixtures because we only separate mixtures. What are mixtures? A mixture is a combination of two or more substances where there is no chemical combination or reaction. Mixtures combine physically in no specific proportion, hence they just mix. Solids, liquids, and gases can be combined to create a mixture. And of course, mixtures can be heterogeneous or homogeneous. And heterogeneous mixtures or heterogeneous mixtures are those where you can see each of the components separately. Heterogeneous mixtures are mixtures where you can see each of the components separately. A typical example is what you see in the picture there. You can see the components of that mixtures separately. All of them. That means that if you want to separate them, the ones, the green leaves, you take them separate. The pineapple, you take them separate. The potato or orange, you take them separate, etc. Another example is a mixture of stone in a soil. You can easily identify stone and soil. Another one is when you have water or cassava flakes, which is popularly known as curry, dissolved in water. You will be able to see the water separately and the cassava flakes separately. So heterogeneous mixtures are mixtures that you can see each of the components separately. However, for a homogeneous mixture, you cannot see each of the components separately. A typical example is salt water. When you have dissolved salt in water, you do not see the salt again. It becomes a salt water or a salty solution. So they are not visible again. You cannot see the components separately. Of course, mixtures can be separated into their components using physical separation techniques or what is called the separation methods. For example, salty water mixture can be separated back into salt and water. When you dissolve salt in water to form a salt solution, the salt solution can also be separated back into water and salt, as the case may be. The same thing when you have mistakenly put oil and water together. There is a way to separate them where you are going to get your oil and your water back. This is what is called separation methods. Another one is when you have a mixture of water and sand. The water and sand can be separated into water, sand. And then of course the other one is also a blood. Blood is a mixture. You can separate the constituent of a blood, the plasma, the white blood cell, the red blood cell, etc. using separation methods. Now to start with, please note that the purpose of separation methods is to obtain a pure sample. The purpose of separation method is to obtain a pure sample. So separation techniques or separation method generally talk about the process by which you obtain pure sample using the properties of the components involved. The components of the mixtures involved, you are using a specific property to separate them into pure sample. Okay, so we are going to be looking at first heterogeneous mixtures. All the heterogeneous mixtures, how we can separate them. In heterogeneous mixtures, you can have a solid liquid mixture. For instance, when you have ice cubes in a drink, you will be they are heterogeneous because you can see the ice and the drink separately, the sand and water in a mixture, and the drinks. So how do you separate solid liquid heterogeneous mixture? Number one is decantation. In decantation, uh, It is used to remove insoluble solid from a liquid that separates into two layers on standing. Again, decantation is used to remove a insoluble or undissolved solid from a liquid that separate into two layers on standing, and the property we use to separate them is their density. A typical example is what I've given the other time, that of the cassava flakes and water. When you dissolve, when you put cassava flakes in water, you observe that there is two distinct layers. The cassava flakes is at the lower layer, while the water will be at the upper layer. Why? Because the cassava flakes has more density than the water. As you can see here, you will see the, let's assume this is cassava flakes, it will be at the bottom here, while the water will be at the top. And how do you separate them? You just pour the water gently into another beaker, and by the time you have done that, the water will be in one beaker, and the undissolved solid, all the cassava flakes, can be in another beaker. So you have said to have decanted. So decantation is said to have occurred. Of course, we understand that decantation might not be an effective method because part of the solids or undissolved solid that can be moved into the liquid when pouring, when decanting, so it did not give a seemingly pure substance. Of course, but there are new innovations about decantation now. You can use a decanter to effectively carry out this method. Now, uh, for instance, we can look at the difference between sedimentation and decantation. Impurities that settles at the bottom are called sediments. Take notes. Impurities that settle at the bottom are called sediments or precipitates. So what's the difference between sedimentation and decantation? Decantation. The process in which sedimentation is the process in which insoluble impurities settles at the bottom of the liquid to form sediments. An example is obtaining clear water from muddy water. Obtaining clear water from muddy water. In another aspect, decantation is the process of gently pouring clear liquid into another beaker without disturbing the sediments. So both of them work pari passu in the sense that there must be first sedimentation, where the water and the sand will have separated into two layers of standing, and the impurities should have settled at the bottom of the beaker to become a sediment. Then the process of now pouring the clear liquid into another beaker is called decantation. You can see the clear difference between them. Now, you can see also the sedimentation here. You can see the sedimentation here. Now, let's move to another one quickly. We go into centrifugation. Centrifuging is another method. Another method of separating solid, liquid, heterogeneous mixture is centrifuging or centrifugation. Is a process where a mixture is separated through spinning. A mixture is separated through spinning using a centrifuge. This is particularly used in the medical laboratory. It is used in the medical laboratory to separate, for instance, sample of blood. It is used when the solid particles suspended in the liquid are very fine or have similar density to that of the liquid. For instance, you can see if you submit a solid liquid mixture to a gravitational force that allows fast sedimentation. These are solid liquid mixture. You will see before the separation, they are mixed together, but immediately there is a centrifugal force spinning them around. The solid component gradually settle down into a particular place. They gradually settle down into a particular place. You will see before saturation, they are all dispersed around the liquid. Immediately after the separation, after the centrifugation, they settle at the bottom. Therefore, the liquid can be poured away, leaving the solid behind. You could see the certification of blood, like I've said, is very important in the medical lab. Before certification, this is how it is. Then after certification, you will see the plasma, the white blood cell, and the red blood cell equally separated. Like I've said, is very useful in the medical lab. Let's go to another method of separating solid liquid heterogeneous mixtures. Another one is the filtration. Filtration is a method for separating an insoluble solid from a liquid. Filtration is used to separate an insoluble solid from a liquid, and the apparatus you use here is the filter paper. The filter paper is used to collect the solid particles. The filter paper is used to collect the solid particles. Now, in a typical filtration method, you are going to have the filter paper immersed in a funnel, a filter funnel. Then the liquid and insoluble solids are poured through the filter paper, and at the end of the day, you are going to have the clear liquid in the conical flask, while the solid will be on the filter paper. The liquid that passes through the filter paper is called the filtrate, while the solid particles that is on the filter paper are called the residue. And this is the typical diagram of a filtration setup. So in a filtration setup, you are going to have the filtrate and the residue. You are going to have the filtrate and the residue. You can also use sand and water mixture. For instance, you can separate sand and water mixture using using filtration. This is the mixture. Immediately you pour them into the filter paper, through the filter funnel, you are going to have the residue, the sand and at the top, which is going to be the residue, and then the water in the conical flask, which is going to be the filtrate. It's going to be the filtrate. Okay. Filtration has a lot of application, even industrially. For instance, look at this filter bed. You can imagine the filter paper as a porous surface. As the size of the pore becomes smaller, separation becomes slower, and so and that's why you can see in we usually use filtration in water treatment industry. Why? Because it is used to remove some certain small impurities. It is used to remove certain small impurities. So the filtration is used in um, water treatment industry. Another application of filtration is we have air filters in air conditioners. The air filters in air conditioner, you have on and air filters in cars. You have the air in our nostril is also used to filter dust, to trap the dust particles that we breathe in and allow the clean air to pass. So there is air in our nostril, and the function of the air in our nostril is to trap the dust that we breathe and allow clean air to pass through. And these are also application of filtration. Filtration can also be used in water treatment industry, like I've said, and of course in chemical laboratory. So quickly, let's look at another one, precipitation. Precipitation is a technique used to separate mixture based on the solubility of its component. The solubility of a compound now depends on the ionic strength of the solution, the pH, and the temperature. In an aqueous solution, precipitation is the sedimentation of solid material from a liquid solution. The sedimentation of a solid material from a liquid solution. Now, uh, let's take for instance in the reaction between silver nitrate and sodium chloride. Generally, precipitation is used to prepare insoluble solids. They are used to prepare insoluble solid. Um, And how do you do that? Let's take an example of silver nitrate and sodium chloride. The end result will be producing silver chloride, which is insoluble. So silver chloride, by the time you mix sodium chloride and silver nitrate, both of them are soluble. Both of them will dissolve, but immediately you add them together, they form a solid substance which come out as a precipitate, which is insoluble. So they will form the reaction between silver nitrate and sodium chloride will form silver chloride, which comes out as a white precipitate that is insoluble. So precipitation is used to produce insoluble salt, to produce insoluble salt. And you can see here you have the solution there. Then by the time you add you have the solution. By the time you add a particular substance to it, you are going to have the suspension. Then at the end of the day, when it settles down, you have the precipitate at the bottom, and of course the supernatant. So precipitation is generally used in chemical analysis, most especially what is called the qualitative analysis. Then you also have a flotation. Flotation is a process whereby a gas bubbles are injected at the bottom of a tank containing a mixture of a liquid and a solid to separate the solid from the liquid. To separate the solid from the liquid. Generally, flotation can be used to separate complex mixture of ores in the mining industry, solution of oil and water, mixture of copper, lead, and zinc. So it is used basically in mineral processing, treatment of wastewater, and of course, recycling of plastics. From the diagram here, you could see how flotation occurs. Air bubbles are passed through. They are passed through a rotator, and an agitator rotates and disperse air into the mixture. It disperses air into the mixture, and you see the mixture's feed. The mixture's feed will contain hydrophobic material and hydrophilic material. It will contain hydrophobic material and hydrophilic material. By the time air is passed through, you observe that both hydrophobic material and hydrophilic material are separated into two components generally. Okay, so and of course the hydrophobic material is carried to the surface by bubbles of air, and they form a fourth. When you pass air, when you have a mixture of hydrophobic and hydrophilic material, you pass air through. The hydrophobic material is carried to the surface by the air bubbles and forms a fourth, which can be collected into another container, and then of course the hydrophilic could not be collected in another container. So this is a process, and like we have said, used in mineral processing, in wastewater treatment, and plastic recycling. Okay, quickly let's look at liquid mixture, which is heterogeneous. For instance, the mixture of oil and water, and the mixture of oil and water can be separated using a separatory funnel. The same density. When you have two immiscible liquids, that means liquids that do not mix. An example is oil and water, or kerosene and water. They form two layers separately, and the oil will be at the upper layer while the water will be at the lower layer. Why? Because the water has greater density than the oil. So separatory funnel method also uses the density of the two immiscible liquids. So when they form two distinct layers like this, we just open the funnel, the separatory funnel tap, and then the water goes down, leaving the oil behind. So you can use it to you could see uh, uh, the experiment here, where you have oil and water separated into two layers, and then you collect the water in a beaker, leaving the oil behind. Generally, separating funnel is used in chemical laboratories. It is used in chemical laboratories. And then, of course, you have the solvent extraction method. You have the solvent extraction method. which is in which a solute can be separated from a solution by shaking the solution with a solvent in which the solute is more soluble and the added solvent does not mix with the solution. The principle of solvent extraction is based on the fact that different substances have different solubility in different solvents. So in solvent extraction, a solvent is used to extract a desired substance from a mixture. A desired substance from a mixture. Um, Solvent extraction is widely applicable in chemical analysis and other fields such as pharmaceuticals, food science, and environmental science. So let's look at solid heterogeneous mixture. When you want to separate two solids that are heterogeneous, the first method here is the magnetic separation. Magnetic separation is used to separate magnetic substance from non-magnetic substance. A typical example is when you have iron and when you have iron filings and sand. What you do, or iron filings and sulfur, what you do is to bring a magnet towards that mixture. The iron filings will be attracted to the magnet, leaving the sulfur behind, and that's magnetic separation, used to separate magnetic substance from non-magnetic substance. It is widely applicable in hospitals. Electromagnets are also used to remove steel and iron scrap at the junkyard. It is also applicable in the mining industry. And of course, another one is sieving. Sieving is used to separate two solid particles of different sizes. It uses the differences in their sizes. Usually, when you have two solids together and you want to use sieving, that means that one of the mixtures is fine or small, and the other is large or coarse. So when you use a sieve, the coarse particle, which is a bit bigger, remain on the sieve, while the fine particle, which is smaller, goes down to the container that is collecting it. Sieving is usually applicable in the mining industry as well. Another method of separation of solid mixture, heterogeneous solid mixture, is sublimation. Sublimation is the process by which a solid changes to gas without passing through intermittent liquid phase. Um, there are substances that undergo sublimation. An example is ammonium chloride, iodine, camphor, naphthalene, and dry ash. These are substances that undergo um, sublimation. And then, of course, there are three common examples of sublimation in our everyday life. For instance, when you put air freshener in your room, you observe that the air freshener is solid, and at some point the solid changes to gas, and of course it replaces whatever odor you have in the room. That's separation. Of course, you have sublimation being used as purification method for purifying volatile compounds. It is used for purifying volatile compounds, and this is a typical setup of a sublimation method. Uh, so sublimation can be used in uh, various ways, but generally for chemical analysis. Now, quickly let's look at few of the WAEC questions here. You have WAEC 2011. The question says the following diagram is a setup for separation of a mixture of palm oil and water. You could see it here. State one physical property of the liquids that will enhance their separation. Identify X and Y and name the apparatus labeled Z. Can you attempt this question? The WAEC 2011 questions. Can you attempt it? Okay, let's look at the answer. The answer here for number one is the property is immiscibility. The physical property here is why? Because the two substances X and Y do not mix, and that's why they are forming two distinct layer. So immiscibility of both of it, palm oil and water do not mix. And the second answer, that's why we go to the second answer. X and Y could be oil and water. You can, if in fact, you can also put kerosene or petrol and water as well. It's accepted because they form two distinct layers, and the Z, the apparatus there, is a separatory funnel. Separatory funnel. The second question quickly is a compound you Quiet 2014. You could see the question there. Can you make an attempt to answer the question? But it's part of it soluble in water. So what's your answer? You should have gotten C, filtration, because filtration is used to separate insoluble solids. Filtration is used to separate insoluble solid using a filter paper. So these are heterogeneous mixtures. How you can separate solid solid, solid liquid, and liquid liquid heterogeneous mixture. In the next video, we are going to be looking at homogeneous mixtures and some of the separation techniques you can use for homogeneous mixtures. Continue to learn.